All right, so now we're going to be looking at things like the square root of 3 times the square root of 2. If the radical are the same, the roots are the same, that means you can rewrite this as the square root of 3 times 2, which then you can do the math and come up with the square root of 6. Please note, if this had been a cubed, you cannot combine, and that one a square, you cannot combine them. But because they're both the square root, you can go ahead and combine them and come up with the square root of 6. Again, you might get something that looks like this. That's all right. You can put it all in one. It's the cubed root of 7 over x times y, and that's supposed to be a 2 over 2. Okay, well, then you just do 7 times y, the cubed root of 7y over 2x. No big deal. You also get things that look like this, and you can just rewrite this as the square root of x over the square root of 25. Okay? But as you go through this, can you take the square root of x? Nope. Can you take the square root of 25? Yes. And the square root of 25 is 5. So you're going to have things like this. So you can break them down into a fraction over a fraction. So that's all this means. You can either have one large one or you can have two ones that you can then simplify. What if you get something like the square root of 63? All right, so here you need to simplify this. And I don't want an approximate answer. I'm going to want the exact answer. So when I do the square root of 65, I can figure out what the square root of 63 is by doing a factor tree. What times what is 63? Well, I get 9 and 7. I'm going to circle my primes. Then I've got 3 and 3. Circle those. So that's the same as writing 3 times 3 times 7. Because I'm taking the square root, I need pairs, I need twins. Okay, so when I have twins, one of them can come out and what's left is left inside. The other way to look at this problem is determine what is my largest perfect square that goes into 63. So the square root of 9 times the square root of 7, I could rewrite it as that. Do I know what the square root of 9 is? Yes, that is 3. And I can't take the square root of 7. Oops. So that's left as 9 times square root of 7. I may have that. If this was, instead of this being the square root of 63, it could be the cubed root of 63. That would mean that when I come down and broken it all down, that means I need triplets and only one will come out. If I don't have triplets, I can't do it. And then I would be looking for perfect cubes instead of perfect squares that would multiply out. I might get something like this. What's the cubed root of 27? X to the 6, y to the 15th. Okay, well, do I know what the cubed root of 27 is? And that is 3. And then the next way to know this is I'll take 6 and divide it by 3. And y to the 15th divided by 3. Okay, so that gives me 3x to the 2nd, y to the 5th. All right, if there's leftovers, if it doesn't go in evenly, if 3 does not go evenly into 15, whatever's left over has to stay in the radical. Here we go. Here's a perfect example of where things won't go in. All right, so remember I can break this up into the cubed root of y to the 11th over the cubed root of 64 and the cubed root of x to the 9th. I still have that negative. Okay, so I'm going to ask myself, how many times does 3 evenly go into 11 for this y? And it goes in 3 times, so I'm going to have negative y to the 3. And how many do I have left over? That's my remainder, and that's going to be y to the 2nd, because that's how many I have left over that don't go in. What's the cubed root of 64? 4. How many times does 3 go into 9 evenly? Well, that's 3 times. What about this? Well, remember how we could break it up. We can put it back into 1, so then I can write this as a square root of 14 over 2. Okay, and I know the fraction 14 over 2, I can simplify that, and that comes out the square root of 7. Okay, so not only can you go forward by breaking them into 2, but you can put them back into 1 and then simplify. Email me if you have any questions or ask me in class.